Welcome, student, to this topic where we'll start first by learning what is a monotone function. And a monotone function is either it's an increasing function or it could be decreasing function. Now, what do we mean by an increasing function? Increasing function, if we graph it, it will just go up and up and up. As long as the x increases, the y will increases. So something just getting more and more. So if we have two numbers, a is smaller than b, then the image of a will be smaller than the image of b. So if this is a, this is b, f of a will be below f of b, which means increasing function. Of course, we can do the same thing for decreasing function, and it will look like something going down, and that will be decreasing function. Now, the question is, how can one tell if a function is increasing or decreasing? How do I know? Well, the easy way is this rule that we will use from calculus. We look at the derivative. If the derivative is positive, the function is increasing. If the derivative is negative, the function is decreasing. So the question reduced very easy in calculus by finding the derivative and check the sign of f prime. If the sign is positive, increasing. If the sign is negative, decreasing. So this is the first thing I would like to tell you, what is increasing, what's decreasing, and how can we tell if it's increasing or decreasing. Second, we have something we call it relative or local maximum. What does it mean if we graph the function? What does it mean I have a maximum? It means the function goes up and then down. We call it maximum. And usually we call it local because it's only in this part of the function. Maybe the function will do this again somewhere else, but for us, we just focus in here. So we just focus in one part, and that's what we call it local maximum. Which means the function is at its highest, which means f of c is greater than f of x. Now, the y value is the local maximum, and the x value is the local maximizer that it caused the maximum. We will see them in the examples, but this is what we call it local maximum. Same thing we can say about local minimum. The function goes down and then up. Whatever we reach here is the minimum. And if it's either maximum or minimum, we call it local extrema. Now, the question is, how do we find maximum or minimum? And the answer is very simple. The answer is in something we call it first derivative test. And what is the first derivative test? It says that we need to find the critical number. First of all, those are the candidate for maximum and minimum. And then we look at the function. If the function goes up and then down, which means it is increasing and then become decreasing, this is a maximum. And if we have the opposite, if the function goes down and then up, that's a minimum. So if the function goes down and then up, which means decreasing and then increasing, whatever we get here is min. So we have maximum and we have minimum. And that's how we find the derivative test. Let's see some example where we will apply all those rules, and I need you to focus with me in the coming. Okay, now let's see an example where we need to find the intervals where the following function increasing and decreasing, and we need to find all the local extremas. Remember, local extrema is either local maximum, where the function attains a maximum, or minimum. So this is a question where we have a step-by-step way to solve it. So step number one, we need to find the critical numbers. So step number one, find the critical numbers. Remember, the critical numbers, it is where the derivative is either 0 or does not exist. So we need to find the derivative. So if you need to find the derivative, this will be 6x squared plus 6x minus 36. Now, in order to find the critical numbers, either you find where the derivative does not exist, and here, this is not happening. The reason why is because I don't have, for example, anything which create a problem, and specifically, we don't have a denominator. So the only case that is of interest to us is to find the critical number where the derivative is equal to 0. So you will get 6x squared plus 6x minus 36 equal to 0. And that will give you only two answers, which is 2 and x equal negative 3. So two different answers and two critical numbers. The next step is we need to write those two numbers on the number line. So just let me take the derivative. I will need this derivative. It will stay with me. So step 2. Find the interval or the intervals or where the function increasing and decreasing. Where the function is increasing / decreasing. And how we are going to find this one? First of all, let me write the derivative back here. Next step is to have the number line. So this is the number line. And in this number line, you write the critical numbers, which is 2, negative 3. What I want from you is to pick a number here between 2 and negative 3 and substitute it in the derivative. That's as simple as this. So let's pick a number and we will call it the test number. So I will pick 0. Now, substitute 0 here and substitute 0 here. If we substitute 0, the answer will be negative 36, which means it is less than 0, which means it is negative. So what you will do, all this area here, you will just do it in negative. So minus, 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 minus. So basically, what you need to do is you need to find where the function or the sign of f prime of x. I need you to find the sign of f prime of x. How do you know the sign? You will choose just a random number. In this case, I chose 0. Of course, at 2, the answer is 0. At negative 3, the answer is 0. Now, how do I know if this area is positive or negative? Choose any number here. So for example, I will choose 5. What I will do with 5, I will substitute in the derivative everything with 5. If we do that correctly, the answer will be just positive. So it will be positive. Positive, 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 positive. Now we do the same thing. We have to choose a number here. So I will choose negative 10. What I will do, I substitute negative 10 in my calculator, and I check the answer. I don't care what is the answer. I care if it is positive or negative. And in this case, it will be again positive. So that's what we will get. Okay, what did we learn after that? We know that the derivative here is positive, so the function is increasing. So I will just draw it as a line going upward, and I will write increasing. What do I know in the middle? It's negative, so the function will be decreasing. And finally, it is positive again, so the function will be increasing. And that's exactly what we have here. So, as a final answer, where the function is increasing, we need to write it as interval, and where the function is decreasing, you need to write it as interval. Let me start with the decreasing one. The decreasing one is only this area here, which means from -3 to 2. So you just write -3 to 2, and you always keep it open. Where the function is increasing, it's start from -infinity to -3. So you will have -infinity to -3. And then you continue from 2 and so on, from 2 to infinity. So 2 to infinity. And then you join them by the union sign. So this is where the function is increasing and decreasing. Remember, those points here are just test points. We don't care about them. You can use anything, just our test points. What's important, it will tell me where it is positive, where it is negative. Finally, in order to find the maximum and local minimum, I will take this one to the other page because I would need it to keep it in front of my eyes. And now I can find the local maximum. So local maximum is at x equal. Now, what does it mean maximum? Maximum means the function goes up and then down. Now, look at here. The function goes up and then it goes down. So at x equal -3 is the local maximum. And its value, or let's say, and the maximum value is y equal, and now you substitute in the original function with -3. So you have to go to the original function and you substitute -3. And that's what you will get is the value for the maximum. And the answer will be 81. So this is how you find the local maximum. Same thing, local minimum is at, remember local minimum, the function goes down and then go up. Where the function goes down, it goes down here and it goes up here. So it will be at 2. Remember, maximum, minimum are the critical numbers. So we don't have so many options, only to see which one of them is maximum or minimum or neither. So at x equal to 2, and the local minimum, which is the y value, is y equal f of 2. And now it means we substitute in the original function by 2. So this is the original function. And the answer will be -44. Now, x equal to 3, we call it maximizer because it is the number that caused the maximum. and this we will call it minimizer, which is the number that is caused the minimum. So we have maximizer and we have minimizer. And here we have increasing, decreasing, increasing. So plus, minus, plus. And that's the question. It's a long question, but the procedure will be always the same. So let's see another example where we will do exactly the same thing of what we just did. So we have to break this question into 3 steps. Step 1, we need to find the critical numbers. And in order to find the critical numbers, we need to find the derivative, which is minus 4x power 3 plus 12x squared. And now we have 2 options to find the critical numbers. Either the derivative does not exist, which is not happening in this case. And the reason is we have no denominator. The other case where the derivative is equal to 0, which means negative 4x cubed plus 12x equal to 0. And here I can take 4x as common factor. So just get negative x plus 3 equal to 0, which means either x equal to 0 or x equal to 3. And those are the critical numbers. So we find the critical numbers. Step number 2, we will put them in the number line, and then we will see if the derivative is positive or it is negative. So let me just take the derivative with me to the next page. Step 2, we need to find the interval where the function f of x is increasing / decreasing. So how we will do that, as we just mentioned now, we will have the number line, we will have the derivative, just paste it here. And now you need to tell me what is the sign of f prime of x. So we have only 2 numbers. We have 3 and we have 0. Now, what I want from you, choose any number between 0 and 3. I will choose 1. I will not write it down, but I choose 1. What you will do, substitute 1 here and 1 here. Well, if you do that, the answer will be 8, which is positive. I don't care about the exact answer. All what I care is I get positive in this interval. Now choose any number in this range. I will choose negative 1. So substitute negative 1, negative 1. The answer again will be positive. That's fine, it's positive. Finally, choose any number in this area. I will choose 4. So you substitute 4 and you substitute 4. And here the answer will be, definitely will be negative. So it will be minus, 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 minus. So what happened is, if it's positive, it means the function increasing. If it is positive, the function increasing. So it is increasing in this area here, increasing again, continue increasing in this area, and finally it goes down here to be decreasing. So if I just want to recap what we did, where the function is increasing, it's start from minus infinity all the way to 0. That's the first part. And then it continue from 0 to 3. Everything should be open. And then there is a union between them. Where the function is decreasing, it will be just from 3 to infinity. And that's the final answer here. Now, in terms of local maximum and local minimum, we can notice the only place where the function goes up and then down is at x equal to 3. So if I just try to squeeze that here in step number 3, find local maximum / minimum. What is the local maximum and local minimum? First of all, there is no local minimum. Why? Because if you can see, we don't have the function goes down and then up. It's either going up, or it once go down and it will never go up again. So no local minimum. However, if I just take this statement here, we have a local maximum. I'm just gonna write it down here. So we have a local at 3, exactly at 3. So we go to the original function and substitute x equal to 3. So we substitute here 3 and here 3. And that will be the local, substitute, 3 in the function solve. It will be 32. So here will be just 32. And that's the local maximum value. So always this table, this interval, will help me to find increasing, decreasing, as well as maximum, minimum. Just